Good morning, students.
Good morning, sir.
So in this micro-teaching class, we will introduce the skill of using Smartboard. Okay. So nowadays we move from Blackboard to Smartboard. So we will see how Smartboard is used. Okay. So this class you can also use your mobile phones. Is it okay for you?
Okay, sir.
So for this, you install the app VCast Sender. Okay. So have you installed that app?
Installed, sir.
Okay. So after installing, if you open the app, you can see two icons. One is receive, the other one is send. So you select the receive and then type this. Whatever here, you can type this. 6TDTU8. All alphabets are in capital letter. So if you do that, now you can see whatever in the view board that will be also reflected in your mobile phone after entering. Okay. If that is you show the mobile phone to me, towards me. Just turn it. Okay. That's right. So leave it and keep it. So now whatever is there in the view board, it will be reflected whatever we teach. That is the advantage of using Smartboard. No need of taking any notes. All that it will be recorded in your mobile phone. Go for the my view. This is the icon to open the class. So my view board. So here only we need to write my view board. Here two ways we can go for my view board. One is directly the person who has registered. We have to register. I have registered, therefore for me it will allow. Otherwise, general it will be open, but we cannot get all the icons access here. If you are not registered, only registration people will have all the access of the buttons here, the lower buttons, whatever you have here. So one way I can scan this, I can get inside the person who has registered. The other way, the registered person can type their mail ID and password. So two ways, and that app is companion app. So I am going for it. So again, if you go to Play Store, you can get companion app, Viewboard Companion. You have to download it, and after downloading, once you have registered with our IT section, we have requested for it. If you are registered, then you can scan this and you can enter this. So I am getting inside by signing in. So now it is being signed in. Once we sign in, so these all things are operational. If you are not registering, many things may not be operational. So we go for it. So now today's class we are seeing models of an atom. So here you can use this, and if you want to increase the size, so you can increase the size. I have decreased, so normal one. So in today's class we are going to see three models given by the earlier period. So who first said the model of an atom? Who first said? So Thomson. So Thomson is an English school teacher. He is a teacher. He worked as a teacher some 200 years back. So in 1801 roughly, those years, 226 years back. So he gave a model of an atom. Approximately it is like this. So an atom model is a spherical in shape, and in which the positive charge is fully smeared, a negative charges are embedded. So this is the model of an atom. The total positive charge is equal to the total negative charge. That's what Thomson said. So any resemblance in the day-to-day life, this one?
It's like watermelon, sir.
So it looks like a watermelon, whatever we eat in the summer days. So a watermelon will be having that red color you see in a watermelon. The red color is the positive charge fully. What is the other thing in the watermelon? Seeds. That will be black in color. It will be embedded. So the same thing, the negative charges are embedded in the positive sphere. Any other example?
Putting with plums. It's like putting with the plums.
It's a plum pudding model. So it's also like plum pudding. So two examples we can give, whatever we see in day-to-day life. So this is Thomson's atom model. So it ruled the world for over 100 years. Almost 100 years. So this was in 1800s, 1801. And at the end of that century, 1896 somewhere, the another model has come. So the other model is Rutherford's model. So Rutherford's atom model. So here what we do, we will see an experiment by the Rutherford. So for this we will take the image. So here is a box. This is called as a magic box. So here with this we can go for inserting multimedia resources like images, images on the internet, video files on the internet, whatever. And these ViewSonic ViewBoard, they have some video files that also can be taken. So here we have one option, add photos, videos and audio. So there import is there. I have already stored that experiment, the image of an experiment. I am taking it from the local drive. So this is the folder inside the, so here we have, I think it has come. Got that. So you can select a particular image and this can be resized. Whatever size you want, you can reduce. So this is an experiment of Rutherford and his assistants. This is the name of this experiment is gold foil experiment. Rutherford's gold foil experiments. So these are whatever you see, those are the spheres. Each sphere, they are the atoms, gold, atoms of gold. They have taken a thin foil of gold. So this is the thin foil of gold. You are seeing in atomic size. These are each individual atoms, to which you can see few rays. So these rays are alpha particles. So they have passed alpha particles by taking a small thin foil of gold, and to which alpha particles are being sent. So what is happening in that experiment?
One or two.
Many rays are passing through, some are getting reflected. So you can see this is getting reflected, this is getting reflected, and still one more.
One or two rays take.
One or two rays, they are 180 degrees. 180 degrees it's coming back. So when alpha particles are passed through gold foil, many rays are passing through the atoms. So you have to visualize in atomic level. Okay. So many rays are passing through and it comes back the backside. And very few it's getting reflected like 40-50 degrees, and rarely very few, that is 180 degrees, it bounce back. So this was the observation from the experiment. So this is from 1801, this first model, this second 1896, around 100 years, and based on this experiment they proposed a model. Okay, there is a change in the model. So here we said a positively charged sphere in which negative particles are embedded. Now we have to see, based on these experiments, see when many rays are getting passed through, when many rays are passing through the atoms, what we can get it from it? When many rays are passing through atom and it comes back, it means that there is a much empty space in the atom. So if you take an atom, if many rays are passing through, there is a much empty space. Okay. And what still we can propose? Where we are getting 180 degrees back? At the center we are getting 180 degrees back. So if the center repels back at 180 degrees, what is that center made up of?
Positive charge.
Why you are saying positive charge?
Alpha particles.
Because alpha particle is also a positive charged particle. If the center would have been a positively charged particle, it will be 180 degrees repulsion. So based on this, they have proposed a atom model which we call it as Rutherford model. That also we will take it from the web. So now I am going the previous one. So one image I drew on the board. The second image I took it from the local folder. The third image I am taking it from websites. We will search in the web. Let us download and into for our class Rutherford atom model. So here it is there, and here is Rutherford. So it has come here. So we can close this. So I am taking to the place where I said no sequence. While we are seeing components, we said sequence. So wherever we want, I cannot place it here because it will merge with Thomson. Therefore, I am taking it here. So this is the atom model based on the gold foil experiments. The center we have positive charge, and that is protons. They name that as protons, and it is inside the nucleus. So the center part is named as nucleus. By this time, they named as nucleus, and these are negative particles. Negative particles revolving around the nucleus. So this is the atom model. So center we have the nucleus in which positive charge is there, and the negative charges are revolving around the nucleus. So it is totally against the Thomson's model, which they said it is a positive sphere in which negative particles are emerging. Here positive charge is only at the center, the negative particles are revolving around the nucleus. So this is the up to now we have major modifications of the Thomson's model. And again there is one drawback in this model. Any can say what is the drawback of this model? Rutherford's model based on the experiments. According to the physics, according to the kinetics, if a negatively charged particle, if it moves, any charged particle, so any charged particle, if it moves, it loses its energy. Any charged particle, if it moves along a path or if it rotates, whatever, if it moves in a straight path or in a rotational path, it loses energy. Once if everything loses energy, finally the electron will go and stuck in the nucleus. All the electrons, since it is a negatively charged particle, it revolves around and it loses all its energy, and finally it goes and merges with the nucleus, and therefore there will not be any shape for atom. The spherical shape you cannot see. So therefore this is the drawback, and this is rectified by the third man. What is his name? Niels Bohr. So this is another, also the student of Rutherford. So Bohr is the student of Rutherford, and I will say only one statement by the Rutherford for this experiment. That time I missed. So that 180 degree, it comes back, no, 180 degrees, what he said is, suppose if there is a tissue paper, so far away from me, if I shoot the tissue paper with a gun, that bullet straight away comes and hits me. That's what he said after this experiment, and then framed this model. It has a little drawback of the loss of energy by a moving particle, and this was rectified by Niels Bohr. Now we go again to the magic box, and this time what we do, we download a video from the YouTube. So videos, there are two options. One, you can go to the ViewSonic viewboard itself. This is ViewSonic viewboard. They have their own built-in videos, that also we can see. Otherwise, the major resource is in the U team, so we can go for it. Bose. So again, we have to search it, and many things will come. I'll take the first one.
Also quantized. This means that an electron can't have any imaginable energy, but can only...
So, like this, you can download the video and it can be played. Actually, we have to place in this place, it will be better. And what they have, how they have rectified, how Bohr's model has rectified the Rutherford's drawback. So, center is the nucleus, it will be positive charge. Electrons are revolving around the nucleus. A charged particle revolving around the nucleus. What they said, how Niels Bohr has corrected. So it's revolving around, but it will not radiate energy. That's what he said. So all the charged particles revolves around the nucleus, but it will not radiate any energy. And every electron goes around in a specific path, as like Earth revolves around the sun. So the path will not be getting changed. So that's what they modified. So this is the third model of an atom. So now we go for a small interaction. Name the charge at the center of an atom. So this is for an interaction. Now you can open your mobile phone, scan this, open your mobile phone, scan this. After scanning, it goes to a website, or you can, where you have to enter your initials and then answer, and then send your answer. My question is, name the charge at the center of an atom. You have to type the answer. After typing, keep sending. As like in WhatsApp, there will be one triangle like icon, you can send the answer, and the answer will be coming to the board. So use your initials, 2 initials. Yes, AR answer has come. At least some, can we get some 4 or 5 so that we can show to all. So this is the interactive part of the viewboard. You can go for quizzes, you can go for polls, you can ask question, so that every student will be in interaction mode. So this, yes, the other one has come, VS has come. So many things. So here there is one option, reveal all answers. So you can see, this is the answer. If you click reveal all answers, so all the answers will be revealed. So whomsoever answered, their answer will be coming. Okay. So with this we end our micro teaching. Okay, thank you all.